This is Dr. Matt. You probably heard about quantum physics or quantum theory or quantum mechanics or whatever quantum you heard about. Today we're going to talk about quantum mystery. Because quantum physics is pretty mysterious and weird, and some people didn't like it, don't like it actually. And Albert Einstein didn't like it. Yeah, Albert Einstein, the and there's also another guy who didn't like it, an Irishman called John Bell. And he thought he could prove that, quantum mechanics was just crazy. So what is a quantum mystery anyway? Actually, what are quantum mysteries? Because I can tell you there's more than one mystery about quantum physics. For instance, how can physical events be totally random even if you know all potential causes and their implications? Or how can a message be instantaneously sent 1,000,000 miles away since it has been proven that nothing can go faster than light? Yeah. How can rational logic be in contradiction with reality? That's a good one. How can a cat be at the same time alive and dead? Okay. Anyway, to answer those questions, there were two camps. The realist camp, led by Albert Einstein, and the stochastic camp, led by Niels Bohr and his student Heisenberg. For the realist camp, there's something here. Even if you don't look at it, it's there, it's fine. And if you know all the causes and all the rules and all the implications, you know for sure it's going to be over there, in the future. For these guys, no way, man. You don't even know if it exists if you don't see it or if you don't measure it. And for sure you won't be able to tell where it's going to be in the future. You can give a probability that it's going to be somewhere in the future, but that's all you can do. Even if you know all the reasons and all the rules in the world and all the causes that can make these rules happen. Okay. Well, it's been a fight like this for almost 100 years, Even today, people... So anyway, with my typical French arrogance, because I'm French, therefore I'm arrogant, Not only I'm going to show you that the best physicists and mathematicians came to crazy conclusions about our physical world, but also we're going to follow together John Bell's path of thoughts, his reasoning. John Bell said, okay, I'm going to build an equation, and upon that equation we're going to do an experiment. And this experiment will prove that not only, this is crazy, quantum physics is crazy, but also it's incomplete compared to Einstein's theory. So that's what we're going to do. It's pretty fascinating because John Bell's idea was a brilliant idea, actually. So, we're done with the introduction. Let's see what comes next. Maybe you don't like math. Maybe you had bad math teachers. Just kidding. Anyway, if you really want to understand this presentation, you have to derive by yourself the conclusions, and for that you need math. So what I'm going to do is give you just the necessary tools you need and explain to you how to use them and why we use them. It won't be something like, curl is defined as a vectorial cross product of the gradient operator by a vector field defined as a linear map over a differentiable manifold. Anyway, that way we'll be able to understand Maxwell equations, which have been ruling this world, in terms of electromagnetic waves, for 150 years. And with that and the Malus law, Malus was a French guy. Yes. Yes. Oui. Anyway, with Maxwell equations and Malus law, we'll be able to derive Bell equations, or an equation if you want to call it that way. And using that, we'll be able to see how an experiment can finally prove us why quantum physics is weird and also whether it is a better theory than a classical theory. So fascinating. So much fun. And then we'll draw some conclusions from that. So, are you ready? Let's go!